What's up, chat? What's happening? So we're gonna build a blog in WASM and C, because why not? Why am I looking at this? Okay, I'm gonna sign into. I'm gonna use fly.io for the actual project. So I'm just running fly launch. I don't have this on because I want to probably do some stuff behind the scenes real quick. Probably doesn't matter a ton if you see stuff, but right now I'm logging into my domain, my DNS. Going to add okay, so I'm gonna add like a certificate, like create a custom domain, all this stuff. So I'll need to go to okay, sorry. Create a CNAME record. Okay. Do. Actions. Add new record. CNAME. At. So root. Okay. So I've added the CNAME. sorry, I created another C name. I'm just doing some shit behind the scenes here, y'all. Add C name. Okay. I mean, for now, it doesn't matter too much. Okay. Let me go back and turn this on. Okay. Anybody watching? No one's watching. That's great. Cool. Create a HTTP server in C. Okay. Oh, I like this one. So we need, okay, yeah, we need application layer, HTTP will work for us. TCP is good. Transport, IPv4, I guess. Okay. Okay, so let's get started. We're in the blog here, and let's create a thing called server.c. And yeah, yeah, print hello world, sure, let's just do that, I guess. Main. Sure. And let's do this here. Yep. So GCC server. Okay, and then server. Cool. Yep. Okay, so we're going to implement the socket. Implement a TCP socket, but let's also inspect what a socket is. Okay. So I'll do man socket. So socket creates an endpoint for communication. From we can read that we need to include the syssocket.h header file, and then we can create a socket endpoint to communicate by using the function socket2. This function returns a file descriptor, which is an integer. The arguments that it accepts are domain type protocol. Look, okay. Syssocket h. So we should be able to include syssocket.h. Cool. Okay, that compiles, that exists. Okay, the argument type specifies the communication semantics, so which socket types we need to use here. So we want to create a TCP web server, so which of the options resembles that? I'm going to put this in the description of the channel. I'll just, okay, create like readme.me blog. Resources used for building this. Okay. Phew. Okay, so sock stream, duplex byte stream is kind of a type that ensures data is not lost or duplicated. Okay. Protocol. According to the main page, is the particular protocol to be used with the socket. It's common that there exists only one protocol that will support a specific socket type. In our case, we're choosing sock stream as the type, and as stated by man7IP man page protocol is the IP protocol in the IP header to be received or sent. In this case, creating a TCP socket where the valid value is at or 0 for TCP sockets. Okay. Return value int. The int socket, int domain, int type, int protocol function returns an integer, which is a file descriptor for the socket. The file descriptor is a unique number that identifies an open file. In this case, this is our socket, and just as a regular file, we'll be able to read and write to it. When an error occurred, it will return the value -1. It will also set an error number, which we can use to properly handle errors. From that last section, the return value of the socket function, the error no will be set. Let's check there's a man page about it. Okay. So error number, error no, is an integer variable that can be set to signify what exactly has gone wrong. In order to inspect what kind of error was raised, we can use p_error to print the error. It will translate the error code that has been sent in the variable to human readable form. Let's check the man page for p_error. So print error. Yeah, I guess those are both part of the standard, or p_error is part of standard IO. And then error number is something we should add. Okay, so we got error no. Okay, so yeah, we need a socket file descriptor. Socket file. I'm gonna spell these out just because I'm not as familiar with them, so it'll be nice to be very clear. Socket AF inet sock stream 0. AF inet. So I skipped over a bunch of stuff, but that's cool. We'll come back to it. Where does this come from? AF inet sock stream. Okay, let's see. Does this compile? Let's okay. Unused variable. Okay, so it's still compiled. That's fine. If sock file descriptor is -1, something broke, print error. Okay, let's do that. If socket file, I'm gonna turn off the LLM here because I want to do it myself. Door equals -1. Yeah, we'll print the error and return 1. Okay, cool. Yeah, cool. p_error socket web socket is it just just that. Okay. Return 1. Otherwise, we will print f socket created successfully. Yeah. And okay, let's do it. Make file. Make build run. Cool. So that works. So we've created a socket. We need to bind it to an address, otherwise nothing can be sent or received. Does that make sense? So we bind the socket to a local address and port. Socket is created and exists in a namespace, an address family. Okay, right. So address family is AF, right? Stands for address family. And we need to bind the socket to a local address in order for the socket to receive connections. So there's a bind function, bind a name to a socket. You can see that bind is included in the header file, says socket H, and on success it will return 0. It accepts as arguments sock FD, pointer, adder, and adder line, adder ln. Okay, let's go over each one of these. That's okay. Sock FD, this is the file descriptor. We already did that. Yep. And we need to use that here as the first argument. Adder, the address structure to which we want to bind the socket to, and it depends on the address family we're using. So let's check what adder needs to look like. We can expect the rules in the name binding by referencing the man page of the communication domain we're using, AFINet. Okay. So address format. Okay, so it's a struct with an SA family T, address family, the import, and the internet address. And then the internet address is a struct of unsigned int32T. So SYN family is always set to AFINet. SYN port. Okay, so let's go back here real quick and say bind. So the first thing is going to be the socket file descriptor, and then okay, so as I said, how bytes are arranged when sending data over a network, an order must be chosen to make sure that on both ends the machine interpret the numbers the same way independent of the CPU architecture. For example, an integer value of 1 represented as 4 bytes will be represented on big endian machines as 0001. On a little endian machine, this would be 1000. Okay? The value of 0001 of the big endian machine would then be interpreted by the little endian machine as the value 16,777,216 and vice versa. As such, like the man page states, we need to call htons 3 on the number that is assigned to the port, like so, htons 8080. It will convert the host byte order to network byte order. See the man page for htons for more information. Okay, SYN adder contains the host interface address and network byte order and is a member of the struct named in adder. The man page states it should be one of the in adder values. These are defined as symbolic constants in the header file netint in.h, or can be set by using one of the init aton, init adder, init make adder library functions to specify a specific address. We can also inspect the POSIX man page to see how the header file should be implemented on systems. Man net init We will make use of the symbolic constant in adder any, and it means any address, which translates to the 0.0.0.0.in add tree any is already in network byte order, so we don't really have to convert it. The man page advises us to convert, so let's just implement it. We do this by calling hton l on the address. But why are we using 0.0.0.0 here? This is just your machine's IP address. Your machine will have one IP address for each network interface. When your machine has, for example, Wi-Fi and Ethernet, then the machine will have two addresses, one for each interface. When we don't care what interface is going to be used, we use the special address 0.0.0.0.0, which is defined in the symbolic constant in adder any translates to this address. Cool. This is all very interesting. In the original BSD sockets implementation and other older systems, the third argument of accept was declared as int star a POSIX. 1G draft standard wanted to change it into a size T star. See later POSIX standards. Okay. On success, the return value for bind will be 0. When an error occurred, it will turn -1, and error no will also be set. Okay. So we've just want to see if anyone's watching. No one's watching. That's great. We created the socket. Now we need to create the address. So sock address. Okay. So in struct sock adder in host adder int host adder len int host adder len is the size of the host adder. That makes sense. Host. Okay. And then we're just going to set some of the stuff in the struct here. So host adder.syn family. Host adder.syn family equals AFINet. And I think, right, it said that this is always the case. Host adder.syn port equals htons port. Okay, yeah, and then at the top we should do make port a constant. That makes sense. So define port 8080. And then the last one, host adder.syn adder.sadder. Host adder.syn adder.sadder is hton l in adder any. Okay, right, and then if we so then we're going to try to bind the socket, right? So bind socket file descriptor. The second argument is the struct adder, the socket address rather. Struct sock adder. And the last one is the host adder len. Okay, so if that, so this is, yeah, if is not equal to 0, p-error web server bind, p-error web server bind, sorry, return 1, yeah. Otherwise, printf socket bound to address. What do I call it? AF, not AI. Not everything's AI, man. Variables incomplete type struct sock adder in. Struct sock adder in. Okay. Call to undeclared function htons. ISO C99 and later do not support implicit function declarations. Okay. Storage size of host adder isn't known. Okay, so what are we missing? Oh, okay. Yeah. So I guess I need to add in. What was it? ARPA. Oh, this is some real shit. This is the original internet stuff, man. This is like real original internet crap. That's cool. Okay, host adder len undeclared. Yeah, let's see. Host adder len. Yep. Host adder. Unexpected expression. Is it though? Unexpected expression for if why doing what? Int bound equals bind. If bound not expected after if. Okay. Oh, okay. Here. Yeah. Okay. Oh, okay. Well, that's fine. That's cool. Server app 8081. Why not? Talk about address. Cool. Okay. Note that we were typecasting adder to the struct pointer struct sock adder in the argument bind function. Since adders of the type struct sock adder in, we need to cast the struct sock adder star from the main page. The only purpose of the structure sock adder is to cast the structure pointer passed in adder in order to avoid compiler warnings. Okay, so a little bit of black magic there, I guess. Okay, so we've created a socket. We've bound an address to the socket. That's two big things. Very cool. Now we're going to listen to that. And here's the listen function. So we've created a socket and bound it to a local address. Now we need to make sure that the socket is listening for incoming connection. We do that by using listen function. That will make the socket available for incoming connections. Let's see what the main page is to show us how to use listen. Okay, so we're going to need to include types.h. Include, what was it, just sys, types, sys. Okay, so then listen returns an integer. It takes in that sock file descriptor, which is an integer, and then a backlog. What is a backlog? When a socket is created with the socket function, it is set to active. The socket can then be used in the connect function to establish a connection to a passive socket. A passive socket can allow connections by passing it to the listen function. In most applications that use stream sockets, the server we will perform the so-called passive socket open, and on the client, an active socket open, since we're creating an HTTP web server and using the listen function in order to listen for incoming connections. The socket that we've created will be a passive socket, and we will use to accept connections from the other active sockets. Okay, so sockfd, that's the same thing we've been passing around for a while. So at this point we can say, yeah, I'm going to turn Super Maven off. So socket file descriptor is the first guy. And backlog. So backlog, this integer will define how many pending connections will be queued up for sockfd socket before it will be refused. For now, we will set this to 128. Okay, that seems fine. So down here, so let's throw this into a constant, define socket max cons 128, and we'll say socket max cons. Okay, so we listen to that. We say if listener not equal to 0, p error web server listen. Is that what it is? Yeah. Okay, cool. I'm just guessing now, and it's working. Return 1, else successfully, yeah. Print f server listening for connections. There we go. Let's try it. Make build run. No such file or directory. Okay. Oh. Sorry, I pulled that from the man pages. I shouldn't have necessarily been doing that. So listening for connections. Okay. Okay, referring. So cool. I'm skipping over a lot of stuff. I mean, not skipping, but just kind of breezing through a little bit. But please read through this article. It's awesome so far. Referring back to our diagram, we've created a socket bounded to a local address, and we've put the socket into passive mode, where we can listen. I'm just going to post this, by the way. Okay, referring back to our diagram, we created a socket bounded to a local address, so we've put the socket into passive mode. Now we're listening for connections. Now we gotta accept them. Okay. Now we're ready to make sure the socket will accept connections. We need to use the accept function, and let's check the man pages again on how we need to implement this. Okay, so we can also check it ourselves too. No. Okay. Accept a connection on the socket. Okay, so it returns an integer, takes the file descriptor, takes that socket address, and then the socket length that we've been messing with before. So function will get the first connection from the queue of the listening socket. Then it will create a new connected socket, and the file descriptor that points to that socket will be returned. The newly created socket is, however, not in a listening state, and thus the original socket is not affected by this call and can be used to accept other connections. When there are no pending connections, when the accept function is called, the call blocks until a new connection arrives. Okay. So let's go back here and So this will take the socket file descriptor. The argument adder is a pointer that refers to a sock adder struct. This needs to be the address of the original socket that we've created, and we need a pointer to that struct here. Adder lang is a value result argument. It points to the size of the buffer pointed to by the argument adder. Because accept can accept multiple protocol families, we need to provide the size of the address that we're using. A pointer is used because the call must initialize it to contain the size and bytes of the structure pointed to it by adder. On return, it will contain the actual size of the peer address. The kernel then knows how much space is available to return the socket address. Upon return from the accept2 function, the value adder lang is set to indicate the number of bytes of data actually stored by the kernel in the socket adder function structure. Yeah, right, so we've already created the adder, right? Sock adder. The original value was an int, so we need to typecast it to socket line T to make it work. Okay. So a little bit of magic, a little bit of black magic there. Okay, I like this. We got this little for loop here. For, I don't know what that does. I don't know what that does, but it looks cool. Int new socket fd equals accept. Get rid of this guy. Accept socket file descriptor. And then we do the same thing later. Struct sock adder, right? Yeah. And then we need to, so it's very similar to this host adder len, but we need to cast it as this socklen t, right? Okay. Cool. And then so if it's less than 0, have an error. Continue. Yeah, so we're just like in a loop looking for stuff. Printf. And then we'll close it. Cool. That looks like it, I guess. So okay, we got a loop. No. P-close. Did I mean P-close? Or is there another? Yeah. So pull in this uni SD. Cool. There we go. Okay, so now we're listening for connect. We have a HTTP TCP server. It doesn't do anything yet, so let's continue on. Yeah, so now we need to actually like do stuff with the data. Yeah. So is this where the passive active socket stuff comes in? Like we create the passive socket and then things are feeding into it. Connection to another socket is created with a connect call. Once connected, data may be transferred using read and write calls or some variant of the send receive calls. When a session has been completed, close may be performed. Okay. We can read and write data by using the read to and write to functions or some variant of send to and receive to calls. Okay. From the man page of send to, we can read that send to provides extra flags that we might use. We just set a connection between the client and the server. We can read the request of the client since we got a file descriptor with accept function, the ability to read function to read the data. Okay, function read will be read up to count bytes for the file descriptor into the buffer. Unsuccessful, return the number of bytes that were read and the file position is advanced, but it's not run error. -1 is returned, and error note will be set as well. The file position keep track where in the file the next character to be read or written. This is offset by being recorded by the kernel on all POSIX systems. The file position is an integer representing the number of bytes from the beginning of the file. The file position is normally set to the beginning of the file when it is opened, and each time a character is read or written, the file position is incremented sequentially. Okay. So accept takes, or rather read, or unread. This argument FT needs to be the file descriptor. This is the new socket. Okay. So there's a file descriptor. That's the new. That's so that's this guy. So I guess somewhere in here. I guess we probably won't close the connection right away. So we will be doing read with new socket FD. Okay, the buff argument is just a void. There's no this guy's size T. Okay. Yep. Buffer needs to be a pointer to the address of the memory buffer that you want the contents of the file descriptor to be read into as a temporary storage. This buffer must be at least count bytes long. In our case, we will be creating a buffer that will be an array of the type car, and because the array name is converted to a pointer, we can use the variable names of the buffer as the argument. We need to provide how many bytes we want to be we want to read from the file descriptor FD to the buffer. This depends on how large of a buffer you're creating. An example will create an array of 2048 characters. Type size, unsize type, integer type, sizes and counts. Okay. So it's platform dependent, but that's fine. Return value is the number of bytes that were read into the buffer, or 0 if the end of the file has been reached. On error, -1 is returned, and error note is set appropriately. The size size T is a signed integer type. Again, it is commonly used by the standard library to represent size and counts, and it holds the byte count of what was read into the buffer. Implementation. First, we need to implement the buffer. We'll do this as soon as the program begins. For now, we will create an array of the type car with a size of 2048. Each car is 1 byte. Don't forget to include the header file on instd.h or unist. Misspelling, or is this spelling? Okay. Yeah, we'll do find buffer size 10. Sure. That makes sense. And then, yeah, I guess we'll do that the first thing. Right out of the gate. Car. Sorry. Car buffer. Gotta get used to how to define those. Okay. Otherwise, seems like everything's sockets the same as before. Everything here is the same. Da da da. Yeah, cool. So then back down to here where we have this read part. We'll do the reading. So. So this is an integer, right? Yeah, int read values equals read buffer and buffer size. Yeah, okay. And if it's less than 0, we throw a read web server p error p-error web server read continue. Yeah. I'm gonna make these a little more consistent. So used to having like like automatic linting that I just kind of take that for granted, but make these a little more consistent here. Same here. Yeah, okay. Let's try it. Make build run. Okay, nothing broke. Okay, now we gotta write stuff. Now that we are able, so one thing I want to do is like, can I ping this thing? Localhost 8080. Okay. Oh, 8081. Connection accepted. Yeah. Okay. It didn't do anything, which is totally fine. Totally fine. But you can see it worked, right? It accepted the connection. HTTP post. Accepted the connection again. So awesome. Go back to that. So now we're able to read the message that the client has sent to us. We also want to relay something back to the client again because we're implementing a web server. We're going to return a simple web page. Again, because we're implementing HTTP web server, we need to adhere to the HTTP protocol. That means that we need to structure our response to these rules. We'll be using the same socket function that we've just read from because the socket is a file descriptor. We will just as with whatever be able to write the socket using write function. Cool. So write looks like kind of the inverse. So it's going to take in the file descriptor, a buffer, and that size decount. So the function will write bytes up to count from the buffer pointed to by buff to the file referenced by the file descriptor fd. On success, it will return the number of bytes written. On error, -1 is returned, and we set appropriately. As mentioned above, the argument fd is the file descriptor that references the socket we've created by calling accepts function. This is also the same as read. Okay, yep. Buff. The buff argument needs to be a pointer to what we want to write as a response. For now, we will use a predefined string that we will add to the server. We can eventually extend this web server to serve actual HTML files, but for now, we will add the following. We'll come back to that in a second. But yeah, we can just do this now. So if okay, so input, output. I'm going to jump down here real quick and check. Okay, yeah, so let's just do this response. I like that. So, car response. Does it take a buffer size as well? Oh, no, because it's just being, yeah, it's being instantiated here. So, HTTP 1.0, 200, okay. Server, web server, C, content type, Okay. This is the actual HTML right here. HTML. Or HTML. This is hyper prior back soon. All right, so we got this hard-coded ass response. Love it. And then we're gonna write the response in the string length. So it'll just be response, response, expected. Oh no. Sorry, that was the close. Equals write. Yeah, write new socket response. Stringlen response. If output less than 0. P-error web server write. Continue. Call Sterling. Call the undeclared library function Sterling with type unsigned long. Unsigned long. Car response. Oh, I probably need this string.h. So that's not something I've used before. Okay, that's going to get rid of the warning there. Okay. Dude. Yo, awesome, 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 awesome. We're posting this. We're posting this. Screenshots. Make, build, run. All right, I guess it shouldn't. Yeah, I should figure out a limit to get requests, but that's fine. Yeah, so let's go to localhost 8081. Yeah, it works. It works. Dude, I have half a mind to, not half a mind, I'm gonna do this. So we can split this up a bit too, right? There's no reason we can't do just do like is it bold or is it like emphasis? I don't now I'm doing HTML directly in here. Emph? Is it just emph? Uh-oh. How is the server already in use? Well, doesn't matter. Just do that. Boom. Look at that. Strong. That's what it is. Just B. Okay. Oh man, I'm not closing these. I'm not closing these connections, am I? That is hilarious. So I'd like to put this in Docker, I guess. Put C web server into Docker. Let's just ask Claude. I have a simple C HTTP server I want to put in Docker. Boom. Is it that? Is it just that? Server. GCC. I'm going to do the W wall. Call it 8080. That makes sense. Docker build -t server. Yeah, we want to make it tiny, right? Docker run server. What? Yeah, I need to change this one, right? Server. Let's do this here. Docker. Docker build -t server. Docker run. That's called blog. Yeah, it's called blog. Make Docker kill Docker run. All address already in use. That's fine. Need to kill shit, I guess. How can I kill? I forget the syntax for this all the time. On port 80. Kill dash kill dash 9. TI. Huh? Oh, whatever. I guess it's just not there. Let's see. Okay, some Kubernetes crap. Kill 436936. Whatever. Here's what we do, right? We just. It doesn't even matter, man. Internal port, say 8085. Bucket. Shared memory. Don't need that much, but whatever. Call this. We'll keep it this way. That's fine. Make build run. Yeah, there's nothing. Oh, what's going on here? There we go. Yeah, okay. Alright, might be. So make Docker build, make Docker run. Okay. Let's see. And if we go to 8085, boom, it works. It works. It's absolutely working. Fly. That's it. We're done. We're done here.